All right, so chapter 5, we studied polynomials, as you remember, and you should know what a polynomial is, okay? I was just teaching the grade 11s. We're studying in-depth polynomials in grade 11 right now. So it's a good idea that you understand the basic parts of polynomials because they're going to come up a lot in math in high school. So a polynomial is either one term, so it can be a single term, or the sum of terms. And when they say sum of terms, you can actually add negative terms as well. So the sum or difference, really, that really means or difference, so or subtraction. Oops, two F's. So the sum of terms could be sum of positive or sum of negative terms. We have to remember that. So it could look like a sum or a difference whose variables have whole number exponents. Whole number exponents. For example, this is a polynomial here, okay? There's three terms, and they're separated by addition or subtraction, okay? And the exponents on the variables are whole numbers. You can't have any fractions as exponents. That's not a polynomial. I mean, that exists, and we'll study more of that when you get into grade 10, 11, and 12. It can't be, so the exponents can't be like square roots. They can't be fractions. They can't be negative. Okay, so whole number exponents would be 0 or 1 or 2 or 3 or 4 or 5 or 6 all the way up. Okay, all right, the numerical value, that's the number for a term. The numerical value is the coefficient. So in this case, let me just zoom in a bit. I feel like it's a bit far away for some of you at the back. So the coefficients here would be 2, positive 2, positive 3, and this is, what is this last number? Is it a coefficient? No, it is a constant term. So this is the constant term at the end, negative 5. That's right. So if there's no variable, if it's just a number, that's a constant term. The degree of the polynomial, okay? So the degree of the polynomial in the variable m, let's say, is the highest power of m in the polynomial. So back to this example up here, this is degree 2 because the largest exponent on the variable is 2. A polynomial with one term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and we actually did talk about 4 terms this year, didn't we? Anybody remember the name for 4 terms? Yes, is a quadrinomial. So quad for 4, rinomial. Quadrinomial. Yeah, that's a bit of a bonus. That might come up, but yeah, that's what 4 terms is. Okay. So understanding what a polynomial is, to name the polynomial, all that's pretty important. Do you remember what we do if you have, what's the degree of a polynomial where there's more than one variable? You guys remember that? All right, so yeah, for a monomial, like for example, C here, okay, this 3 there is the degree of that monomial, because the degree of, if there's more than one variable, you add up all the exponents for that term, and that's the degree. So this is degree 3 here. This one, 2 plus 4 plus 1 is degree 7. Yeah. All right. Okay, good. Let's keep going. Algebra tiles. So what we learned was that if you have a squared term, like p squared here, or if you have a p term, just a single variable with exponent 1, or if you have a constant term, those 3 things can be modeled by algebra tiles. And so we worked with algebra tiles a little bit. The big squares are the squared variables. The rectangles are the single variable to the power of 1. And then the little squares are the constants. So in your textbook, the yellow is positive, the red is negative. And we did shaded was negative, right? So the white empty squares were positive and the shaded ones were negative. That's what we did in our notes. So like terms, okay, anything with the same shape, those terms would be like, right? This exact same shape. Now they can be positive or negative, so a positive big square tile and a negative big square tile. Those would still be like terms, right? And here's some examples here, okay? So these 2 are like terms right here. So you can add up all of those, which gives you 3x squared plus 2x squared would be equal to 5x squared. If you have a negative x and a positive 3, you cannot combine those because they're not like terms. So you have to write that as negative x plus 3. Okay? Only if they're like terms can you combine them into one term, right? So like these are two terms right here, and I've combined them into one term. These are two terms, but they're different, so I have to leave them as two separate terms. Questions there about algebra tiles or like terms? No? All right. We're flowing along here. Good. Okay, operations with polynomials. So this is a really important part of this chapter, obviously. To add polynomials, all we do is combine like terms. And remember with the brackets, when you add, you can just eliminate all the brackets. The brackets don't really mean much if you're just adding. So 3r squared plus 2r squared. That's 5r squared. 5r plus a negative r. So that's like 5r minus r is positive 4r. So you just combine all the like terms. It gets a little bit trickier when you're subtracting. And when you're subtracting, the best thing to do is to, I would say, and this is the way we learned it, is to change this to a sum, to adding, and then change all the signs of the terms in the second polynomial. Okay? They sort of didn't really do that here. This is an example where they subtracted all of the terms, but then you get into, you know, multiple signs and stuff. So you can do it anyway. You can do it this way like they show in the book, which is slightly different than what I taught you. But a good idea, I think, would be to go 3r squared plus 5r, and then change this minus to a plus. And when you do that, you have to change the signs of everything inside the second bracket. So when we drop the brackets, it's 3r squared plus 5r. This becomes just a minus 2r squared plus r. And then you can go ahead and gather like terms. 3r squared minus 2r squared is 1r squared. We don't write the 1 as the coefficient. And then 5r plus r is 6r. So a good idea to add the opposite when you subtract. Add the opposite of all of the terms. All right, multiplying, the one thing we want to remember for multiplying is the distributive property. So if you have a single term multiplied by a polynomial that has more than one term, you have to make sure that you multiply the first one times all of the polynomials in the group there. So I would strongly suggest you show your little arrows there so you don't forget. And 2t times 5t would be 2 times 5 is 10, t to the 1 times t to the 1 is t to the 1 plus 1. So you add the exponents when you multiply. And then 2t times negative 3 would be negative 6t. And you guys all should be pretty much pros at this now, so this is just review for you. But one more, I'll go through the dividing of the polynomials. This can get, again, just like subtracting, this can get a little tricky. So please be careful. I would strongly suggest this step, okay, when you do this, to separate all of the terms on the top and write them as separate separate fractions, okay? Good idea to do that because you make fewer mistakes, I think. So 21x squared divided by 7x, and then you have minus 14x divided by 7x. And then you do each one of these individually, you break it into smaller problems. And when you do 21x squared divided by 7x, you do 21 divided by 7 is 3. X to the 2 divided by x to the 1 is x to the 2 minus 1. You subtract the exponents. And so that gives us x to the power of 1. And we don't write the 1 as an exponent either. Okay, and then 14 divided by 7. This is, I saw a lot of you make a mistake here on this yesterday when I was walking around looking at your work. 14 divided by 7 is 2. X divided by x, okay? Please don't put, hey, that's just x. You're not adding or subtracting, so you don't keep the like term, okay? You don't keep the variable, you divide those out. That's x to the power of 1 divided by x to the power of 1. So it becomes x to the power of 1 minus 1, which is x to the 0, which anything to the power of 0 is just 1. So that's like 2 times 1. That's what that simplifies to. Another thing to remember is any quantity or any value divided by itself is just equal to 1. So it's like it disappears. It doesn't really disappear. It's times 1 now, but anything divided by itself can be kind of eliminated. All right? So just please, please, please keep that in mind. I know there's a lot of little rules that you guys are learning here. But if you have like x, y, z divided by x, y, z, that's just 1. It's 1. If you have x to the 17, y to the 3, z to the negative 500, and you divide that by the exact same thing. It's just 1. Okay, anything divided by itself is just 1. All right, questions. Please ask any questions if you have any from this review right here or from this chapter. Any questions at all? Okay. I've given you a lot of time to work on your notes package questions, your textbook questions, the review. I've gone over this review with you. So I've done all that I can in class here to prepare you. I'm going to give you a little bit more time, and we're going to do one more little review activity. But please remember, this is the first test you've had with me this year, okay? So please remember that in high school now, in grade 9, you have to study outside of class, okay? It's not like elementary school. Maybe some of you in elementary school is like, this stuff is so easy. It's been easy for me for 2 weeks. I don't have to study. I know it. In high school, you got to study. Even if it's just going over your cue card and reading it over the night before or whatever, even that's minimum. Okay, you got a cue card and you're studying. Do an extra few questions on something you're weak at. But you have to study outside of class. Okay, if you get into that habit in grade 9, you will be successful in high school. If you don't think you ever need to study outside of class, things are going to pile up really fast, and you don't really normally get this much time in class to study. So please get used to the fact that, hey, I got an exam, I got to study the night before for sure. Maybe a couple nights before would be best, just to go over stuff. Make sure you have all your homework done. Make sure you have your cue card if you're allowed one. Make sure you have that finished. Don't leave anything to the last minute. Okay? So no questions about chapter 5? All right. Awesome.